We're taking a look at practice question set number 20 here. Right away, we got a Michelson question. It says, in Michelson-type experiment, the path followed by a beam of light when the 8-sided mirror is at rest is shown below. 8-sided mirror, this is standard. This is what we're used to seeing, although we got to watch out for that because every once in a while it isn't an 8-sided mirror. Maybe it's 6, maybe it's 12, whatever. The detector indicates a maximum signal. As the 8-sided mirror begins to rotate, the beam of light no longer follows this path, and the detector indicates a decreased signal. The diagram is not drawn to scale clearly. Once the 8-sided mirror is rotating, the frequency of rotation for which the detector will first detect a maximum signal is what? We know how to deal with this, right? Every single time we get one of these Michelson questions, we start with what? Two equations. What are they? V equals d over t, and t is equal to 1 over f. Good. Little t stands for the time for? Yeah, it's the time that it takes the light to go from here to here and back again, which corresponds to the time for 1/8 of a rotation. Good. And big T stands for, of course, the time for one complete rotation. We sub in our numbers, we see what we can solve for here. We're looking for the frequency, so we have to have a speed of light. What speed are we going to use? Well, in the absence of us being given a value for the speed of light, we have to use the only value that we have, which is 3 times 10 to the 8. So let's sub that number in. We do have the distance given to us here. What is it? 60 kilometers, or 60,000 meters, divided by the time for 1/8 of rotation. We'll solve for t 1/8. 60,000 divided by 3 times 10 to the 8. I'm going to say it's 2.0 times 10 to the negative 4. Is that right? Is that right? Now we're going to say, well, we don't want t 1/8, right? If we get little t, remember, we always want big T. If we happen to get big T, we always want little t. So let's turn that into big T by doing what? Multiply by 8. That's going to give me 1.6 times 10 to the negative 3 seconds. And then we're going to sub that into this equation. 1 over 1.6 times 10 to the negative 3 seconds. And that's going to give us, I think it's going to be 625. It's not that I did that calculation in my head. I looked at the answers here and said, well, 625 is the most common one, right? Not 625 per se, but that 600, 700-ish is the most common one. So I kind of made an educated guess on that, knowing that it was probably going to be 10 to the 2 hertz, or 10 to the 2 cycles per second. Don't assume that it is. Okay, if this was a test, I wouldn't have just said, oh, I think that's going to be A. Okay, if this was a test, I would have done that calculation and gotten 625 and then ensured the answer was A. Okay, but if you got to guess, okay, A's the guess to make. All right, let's take a look at question number 2 now. Strong evidence that at least 2 planets orbiting around the pulsar neutron, whatever, star emits radio waves that are detected at 305-meter diameter radio telescope in Puerto Rico. However, the orbiting planet's gravity causes the star to wobble on its rotation. The time that it takes for the emitted radio waves to reach the Earth varies. One difference between radio waves and visible light is that radio waves what? So a question here that clearly, like, we read this information in the box, and it just, like, none of it matters, right? And that happens, right? That's why I say, when you get information, what should you do with it first? Skim it first, right? And then do what? Read the question. Thank you. And then read the question, and then spend a little bit more time going over the information once you have read the question, so that you know what you're looking for, right? We skim this, and then we read the question, we realize, oh, we don't need to go back and look at that now, because we don't need anything from it. What do we know about radio waves versus visible light? Radio waves cannot be reflected. Is that true? No, radio waves can be reflected. Can radio waves travel through a vacuum? Yes. Do radio waves travel at a lower speed? No, radio waves and gamma rays and visible light and whatever all travel at the same speed, 3 times 10 to the 8 meters per second. What about this one? They have a longer wavelength than visible light? Yeah, they do. It's smaller frequency. Okay, radio waves have the smallest frequency, therefore the longest wavelength. D's our answer. Radio waves from space longer than 1/10 the diameter of the radio telescope are undetectable at the Earth's surface. Okay, we were given the diameter of the telescope was 305 meters. That means the wavelength is going to be 30.5 meters, right? It tells me wavelength longer than 30.5 meters or 1/10 the diameter of the radio telescope. What is the approximate lower limit of the frequency of the detectable waves? I'm going to say V is equal to F times lambda. I'm going to say F is equal to V over lambda. V is 3 times 10 to the 8. And this is 30.5 meters. Gives us a value of, I think it's, is it going to be C? Is it C?
That's what it said, yeah.
Okay. 9.8 times 10 to the 6 hertz. Again, if I was going to guess, which I kind of did there, although I kind of looked at the math in my head there as well and said, I think it's going to be C. I would have guessed C right from the beginning. A, like definitely not. Okay, definitely not, because it's 10 to the minus 7. B, possible 32 hertz would be radio waves, although it would be extremely low frequency radio waves, right? 9.2 times 10 to the 9, that would be kind of at that border between radio waves and microwaves, so probably wouldn't pick that one. C, right smack in the middle of radio waves, so that seems to make sense, right? Good? All right, and number 4, which of the following types of radiation has the longest period? Oh, here's one, longest period. I don't think we've had a question where we've involved period here yet. What's the period of a wave?
The inverse of frequency.
Yeah, it's the time for one cycle. Frequency is the number of cycles per unit time. Period is the time for one cycle. So it's the inverse of the frequency. If we're looking for the one with the biggest period, then we're looking for the one with the smallest frequency. The smallest frequency is going to be radio waves. The answer is going to be A. And number 5, an ice rink is lit by bluish light with wavelength of 500 nanometers. The period of this light, we're going to say 1. Period is 1 over the frequency. Oh, but we don't have frequency. Frequency is V over lambda, which is 3 times 10 to the 8, divided by 5 times 10 to the minus 9. That's going to be 6.0 times 10 to the 14 hertz. Once we have that frequency, we can say T is equal to 1 over that frequency. (1.67 times 10 to the negative 15 seconds). And lastly, numeric response number 1, an explosion that produces a flash of light occurs at a distance of 6.06 kilometers from a group of people. The minimum possible time that it takes for people to see the explosion is what? This is going to be a V equals D over T as well. Sometimes people write it C equals D over T, right? What does C mean? C is the speed of light in a vacuum. So it's a specific symbol for that specific situation, the speed of light in a vacuum. It's fine to keep writing it as V, okay, but you can write C if you're talking specifically about the speed of light in a vacuum. All right, we know what that is. We're looking for time here. Let's rearrange that. D over V. Distance is 6.06. I'm going to say times 10 to the 3 meters. Or you could have said 6,060 meters divided by 3 times 10 to the 8 meters per second. That gives us 2.02 times 10 to the negative 5 seconds. We're going to express that as A, B, C, D, so 2025. If we wanted that expressed as a B times 10 to the W, or B times 10 to the negative W, then we would have expressed it as 2.02, right, including the decimal. We don't see that as much, the B times 10 to the negative W. That's, they used to use that notation all the time. Now they tend to use the A, B, C, D notation, but we got to be ready for both of them, just in case.